All right, today we're going to talk about a brand new system called Zeep, and it's tackling one of the biggest and, let's be honest, one of the most annoying problems in AI right now, which is its absolutely terrible memory.
I mean, you know the feeling, right? You're having this great, deep conversation with a chatbot, you think you've explained everything perfectly, and then, the very next thing you type, poof, it's all gone. The AI has absolutely no clue what you were just talking about. It's like talking to a goldfish, and it happens all the time.
So the reason this happens, the technical reason, is something called the context window. You can just think of it as the AI's short-term memory. The problem is, it's a really limited space, and once your conversation gets too long, older information just falls out. It's gone. That right there is the root of the whole goldfish problem. Okay, so to try and fix this, the industry's best shot so far has been this really clever technique called RAG. That's Retrieval Augmented Generation. What it does basically is it gives the AI a library of documents it can look things up in to answer your questions. And look, it's a huge step forward for sure, but it's got one really big flaw.
And this analogy really makes the difference clear. RAG is like giving someone a static library. They can look stuff up, but the books themselves never change. They don't update based on your conversation. Human memory, though, it's alive. It's this dynamic, constantly evolving web of experiences and facts that get updated and connected over time. RAG just can't do that.
And that brings us to ZEP. See, ZEP isn't just another incremental tool. It's a totally new approach. The whole idea is to give AI something that looks and acts a lot more like a real brain. And hey, don't just take my word for it. The researchers who built ZEP, they put it really clearly. Their goal is to create memory structures that are sophisticated and nuanced, just like ours. So they're not trying to build a bigger, better library. No, they're trying to actually replicate the architecture of human memory itself.
Okay, so how in the world does Zeep actually pull this off? Let's pop the hood and see how this thing is actually built. So Zeep organizes everything into this three-tiered knowledge graph. It's like a pyramid of understanding. At the very bottom, you've got what they call episodes. This is just the raw data. Every single message, a perfect, non-lossy record. Then, from that raw data, ZEP pulls out the semantic entities, the important people, places, and concepts. And finally, at the top, it groups those entities into communities, which lets it see the high-level themes and big ideas.
But here's the real magic. The secret ingredient that sets ZEP apart from everything else is time. The whole system is temporally aware. What that means is it doesn't just know what a fact is. It knows when that fact was true. And, this is the crucial part, it knows when it might have become outdated.
Here's a simple example. Let's say you tell the AI your favorite color is blue. ZEP logs that. But then, next week, you say, actually, my favorite color is red now. ZEP doesn't just delete the old fact. No, it marks the blue fact as outdated and creates a new, current, red fact. And it keeps the whole history. It gets that fundamental truth. Knowledge changes over time.
Okay, that all sounds fantastic in theory, right? But the real question is, does it actually work? Well, the researchers didn't just talk about it, they put ZEP to the test against some of the other leading systems to see how it really performs.
So first up, they used the Deep Memory Retrieval Benchmark, DMR for short. This was actually the main test used by the previous champ, a system called MEMGPT. And ZEP didn't just show up, it came out on top. It scored a 94.8% accuracy, just edging out MEMGPT's 93.4%.
But here's where it gets interesting. The ZEP researchers basically said, you know what, this DMR test, it's too easy. The conversations are pretty short, the questions are simple, and a modern AI can kind of cheat by just stuffing the whole conversation into its context window. So, to really see what a memory system is made of, they needed a much tougher challenge.
And that's where the long memval benchmark comes in. This thing is a beast. We're talking massive conversations, really complex questions, stuff that requires you to reason about how things change over time. And the results, well, they're pretty striking. Using GPT-4o, ZEP hits 71.2% accuracy, just blowing past the baseline of 60.2%. And get this, the response time? ZEP took about 2.5 seconds, compared to almost 29 seconds for the baseline model.
Let's just put that into perspective. That's an 18.5% jump in accuracy on a really, really hard test. So ZIMP isn't just a little bit better here. It's a huge leap forward in the AI's ability to actually remember and reason through a long, complex conversation.
And that's not even the whole story. Remember that response time? We're talking about a 90% reduction in how long it takes to get an answer. Zep isn't just smarter, it is way faster. It's because it finds the right information efficiently instead of forcing the AI to reread a novel every single time you ask it something.
Okay, so it's smarter, it's faster. That's great. But what does this actually mean for us in the real world? Let's talk about why this is such a potential game changer.
Look, this is about so much more than just making chatbots less annoying. This kind of technology enables an AI that can actually stick with you on a complex, long-term project and not forget what you're doing. It means it can learn from every single interaction, becoming a real partner that actually knows your history. It could even combine what you talk about with, say, business data to power a whole new class of applications that are genuinely helpful.
When you boil it all down, what Zep represents is a really fundamental shift. It's the difference between having a tool that has amnesia and having a partner that actually has a memory.
And that really leaves us with a pretty cool question to think about, right? If you had an AI that never forgot a thing, an AI that learned and grew right alongside you, what could you build? What would you do with it? The possibilities? Well, they're really just starting to open up.